All right, we're going to look at writing polynomials from zeros and a point on the graph. So we're going to use the degree to determine how many zeros it should have, and then we're going to use the zeros to write the factors, and then we're going to multiply our factors. And if we are given a point, we need to find our a value, and then multiply that in, and then write our polynomial in standard form. So we're going to look right here at example 2. And so we know the n is 4, so that means it has to be x to the 4th. And then it tells us our zeros are x is plus or minus 1 and x is plus or minus 5. So that means that we're going to have x equals a positive 1, x equals a negative 1, x equals a 5, and x equals a negative 5. So we're going to go ahead and write this in factors. So f of x equals x minus 1, x plus 1, x minus 5, and then x plus 5. Now we can FOIL or use the box to multiply these together. So first I'm going to start with the x minus 1, x plus 1, and then I would do your x minus 5, x plus 5, and then you can multiply those things together. So when I do that, let's do the first one, the x plus 1, x minus 1. So when you do that, you're going to get x times x, which is x squared, a positive 1x, negative 1x, and then a negative 1 in the end. Now let's do the back one. You have x times x, which is x squared, 5 times x, which is positive 5x. You have a negative 5x, and then a negative 25 in the end. Let's go ahead and clean these up. So our middle terms both cancel on both of them. So I have x squared minus 1, and then x squared minus 25. Now I can either use the box or FOIL again to multiply these. So x times x, that's going to give me x to the 4th. X squared times negative 25, negative 25x squared. Negative 1 times x squared is negative x squared. Negative 1 times a negative 25, positive 25. So let's write our final answer, x to the 4th. Negative 25x squared minus x squared is going to give me negative 26x squared, and then that positive 25. And then this is my final product written in standard form. All right, we're going to look at the next section, and we'll look at example 4 from there. So now we have what's called the complex conjugate root theorem. With this, it's basically stating that if you're given a complex number, we also have the conjugate of that, so the opposite. So if I'm looking at example 4, I have n to the 4th, so that means we're going to have a 4th degree. I have x equals 1, x equals negative 1, but right here I have x is equal to 1 plus 2i. I also have the conjugate of that, so I should have x equals 1 minus 2i as well. So when I start writing my factors together, I need to include the conjugate. So I have f of x equals x minus 1, x plus 1, and then I have my 2 complex, x minus 1 plus 2i, and then x minus 1 minus 2i. We want to make sure we're careful with our negatives in parentheses. So let's clean this up a little bit before we multiply. So I have f of x equals x minus 1, x plus 1. I get x minus 1 minus 2i in this first parentheses. And then in the next one, I get x minus 1 plus 2i. in the next one. I'm going to use the box method to multiply the complex ones. It will keep everything organized and it just makes it a little bit easier. So I'm going to come down here and I'm going to write, so this is a 3 by 3. So I need to make sure I make my box big enough. So on the top I'm going to have x, -1, -2i. And then in my down, I'm going to have x, -1, +2i. Now I'm going to go ahead and multiply in here. So x times x, x squared. X times -1, -x. X times -2i is -2ix. Next row, I get -1 times x. Again, -x. -1 times -1 is a +1. -1 times a -2i is 2i. Last row. 2i times x is 2ix. 2i times -1 is -2i. 2i times -2i is a -4i squared. Now, if you look through our boxes, you have some things that cancel. This 2ix and this other 2ix, those cancel. We have positive and a negative. This -2i, +2i, those cancel. So when I start writing this, I get x minus 1, x plus 1, and then in the back, I start with that x squared. I have -x, that's going to give me -2x. And I have a +1, but if you remember this -4i squared, that's really -4 times -1, which is going to give me a +4. So I have a 1 and a 4 that I add together in the back, so +5. And if you notice, you no longer have an I. So most of the time when you do this, you're going to get rid of your I. Now let's go ahead and simplify this first part right here, this x plus 1, x minus 1. So when I multiply that, you're going to get x squared plus x minus 1 times x squared minus 2x plus 5. And again, these middles cancel, so I really just have x squared minus 1 times x squared minus 2x plus 5. And again, you can either FOIL that or use box, but I'm going to come down here and I'm going to use another box. This time it's a 2 by 3. So you get your x squared minus 2x plus 5, and then I get my x squared minus 1 down below. So x squared times x squared, x to the 4th. Then I have x squared times -2x, that's -2x cubed. X squared times 5, 5x squared. Bottom row, -1 times x squared, -1x squared. -1 times -2x, +2x. -1 times a 5 is a -5. So f of x is equal to x to the 4th minus 2x to the 3rd. I have x squared, 5x squared minus x squared. That's going to be a positive 4x squared, positive 2x, and then a -5. And then that is my final answer written in standard form. Next, we're going to look at from a table, same kind of concept, except this time we have a point also given. So notice right here, this -3, 2, this is your point. The others are your zeros. So we're going to do the same concept, except this time when we're given a point, we're going to have to find an a value. So when I start to set this up, I'm going to have f of x equals a, and then now I'm going to start listing my zeros. So I have a 0 at -6, so that's going to give you x plus 6. When I have this fraction, I'm actually going to move that 3 in front of the x and then have the 2. But remember, it's opposite, so it's actually plus 2. So that negative, make sure it changes to the opposite. And then you have another 0 right here at 1, so x minus 1. So now I need to find what my a value is. So I can do that by substituting my point into this problem. So y is 2, so I have 2 equals a, parentheses, and then negative 3 plus 6. 3 times negative 3 plus 2. And then negative 3 minus 1. So when I do this, I get a times 3 times negative 7 times negative 4. And again, I can multiply those, and then that can become your coefficient of a. So you get 2 equals when I multiply all those together, I should get 84a, and then now I can solve for a by dividing. So a equals 1 over 42. So when I come over here, f of x equals 1 over 42. And then I'm going to write my factors out again. X plus 6, 3x plus 2, and then x minus 1. And now I'm going to FOIL or box, and then at the end I need to distribute that 1 over 42. So 1 over 42, x plus 6. I'm going to go ahead and multiply these back ones first, and then I'll get that x plus 6 in. So I'm going to go ahead and FOIL those. So I get 3x times x, which is 3x squared. Then I get 3x times negative 1, negative 3x. 2x, so 2 times x, 2x. And then 2 times negative 1, negative 2. Let's clean that up a bit. So you get 3x squared minus x minus 2. Now I'm going to multiply these, and again, I'm going to use the box method. So I'll come down here and use a box. Usually I use the box when we have longer, like trinomials times a trinomial or trinomial times a binomial. Whoops. Made it too big. This is a trinomial times a binomial. So I just need 3 here and then only 2 rows there. So x plus 6 goes there, and then you get the 3x squared minus x minus 2. Now we can multiply inside. So 3x squared times x is 3x cubed. X times negative x, that's the negative x squared. X times negative 2, negative 2x. Now let's do the bottom row. So we should get 18x squared, negative 6x, and then negative 12. I still have that 1 over 42 in front, but I get 3x cubed. I have 18x squared minus x squared, so positive 17x squared. Negative 6x minus 2x, that's negative 8x, and then minus 12. Now I'm going to distribute this 1 over 42 to each term inside the back parentheses. So I get 3 over 42x cubed plus 17 over 42x squared minus 8 over 42x minus 12 over 42. Now, if we can simplify that, simplify your fractions. So 3 over 42 becomes 1 over 14 x cubed. 17 over 42, that's going to stay 17 over 42. And then 8 over 42 becomes 4 over 21. And then 12 over 42 is going to become 2 over 7. And then that is your final answer. So if you can reduce your fractions, reduce your fractions. All right, on number 8, or example 8, I really only want to mention that when you see the word multiplicity, 2, that just means that there's 2 of that root. So it says it has a root at 3, 0 with a multiplicity of 2. So that means I'm going to have x minus 3 and x minus 3. I'm going to have 2 of them. So when you are doing problems like that, if you see the word multiplicity, that just means that there's multiple. And the number it tells you is how many there are. So if it said a multiplicity of 3, then there would be 3 of them. All right. Make sure you look over the other notes that we did not do in the video, and then make sure you start your homework.